Okay, welcome to chapter 2.6, proving geometric relationships. So the essential question in this chapter is, how can you use a flowchart to prove a mathematical statement? I'm not going to spend a lot of time on flowcharts. We're not going to do those. I will introduce them, but I'm not going to focus on them. It says to write a flowchart proofs to prove geometric relationships and write paragraph proofs to prove geometric relationships. So let's take a quick look. Writing flowchart proofs. Another proof format is a flowchart proof or flow proof, which uses boxes and arrows to show the flow of a logical argument. Each reason is below the statement it justifies. A flowchart proof of the right angles congruence theorem is shown in example 1. This theorem is useful when writing proofs involving right angles. So theorem 2.3 states that right angles congruence theorem, or 2.3 is the right angle congruence theorem. All right angles are congruent, and the proof will be example 1, page 106. Okay, so example 1 says, proving the right angles congruence theorem. Use the given flowchart proof to write a 2-column proof of the right angles congruence theorem. So given angle 1 and angle 2 are right angles, we need to prove that angle 1 is congruent to angle 2. Flowchart proof would be like this. So I'm just going to show it to you and talk through it. We're not really going to do these. Angle 1 and angle 2 are right angles. Reason given. The measure of angle 1 equals 90 degrees. The measure of angle 2 equals 90 degrees. Definition of right angles. Therefore, we can say the measure of angle 1 equals the measure of angle 2. Okay, if the measure of angle 1 equals 90 and 90 equals the measure of angle 2, then the measure of angle 1 equals the measure of angle 2 is a transitive property of equality. So then finally, if two angles are equal, then they must be congruent. So angle 1 is congruent to angle 2, and that is the definition of congruence angles. The 2-column proof form of that would be, always start with your given. So you'd say angle 1 and angle 2 are right angles. Reason. Try that again. Given. So angle 1 and angle 2 are right angles, given. And then we can continue by saying the measure of angle 1 equals 90 degrees, and the measure of angle 2 equals 90 degrees. And that is the definition of right angle. If you have an angle and it's a right angle, it must be 90 degrees. So now we know that angle 1 is 90 degrees and angle 2 is 90 degrees. Okay. So now we can say the measure of angle 1 equals the measure of angle 2. And the reason is the transitive property, because if two things are equal to the same thing, they're equal to each other. That's a transitive property of equality. So as you can see, the flow chart or the flow proof is the same as a 2-column proof. It's just that you write a statement and you write the given underneath it and you continue through with arrows like so. All right, so all I'm really doing is repeating what's been said. So then finally, angle 4, two angles are equal, they have to be congruent, and that's a definition of congruence. Definition of congruent angles. Okay, so as you can see, I'm just wanting to make it clear that this is your statement, reason, statement, reason, statement, reason, statement, reason in the 2-column proof. So a flowchart proof is no different than a 2-column proof. I would just prefer doing the 2-column proofs than the flowchart proof. Okay, so here's 2 more theorems. Theorem 2.4 is a congruent supplements theorem. So it says if 2 angles are supplementary, remember that adds up to 180 degrees. If 2 angles are supplementary to the same angle or to congruent angles, then they are congruent. So what do they mean? Well, here's a diagram over here. And what they're saying is angle 1 plus angle 2 is 180 degrees. So therefore, angle 1 and angle 2 are supplementary. They're supplements to each other. And then angle 2 and angle 3 are also supplements to each other because they would form a 180 degree sum. If that's the case, then angle 1 is congruent to angle 3. So it says if angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, then angle 1 is congruent to angle 3. It's very similar to the transitive property or law of syllogism, where if 1 and 2 are supplementary and 3 and 2 are supplementary, you can get rid of that 2, then you can say 3 and 1 are congruent. So we're going to do that proof in example 2, next page. Then there's theorem 2.5, congruent complements theorem. So it's very similar to the supplements theorem, except it's two angles that add up to 90 degrees. So if two angles are complementary to the same angle or two congruent angles, then they are congruent. So it says if angle 4 and angle 5 are complementary, in other words, say angle 4 was 40 degrees and angle 5 is 50 degrees, they're complementary, they add up to 90. So if angle 4 and angle 5 are complementary and angle 6 and angle 5 are complementary, well, if 5 and 6 are complementary and they have to add up to 90, and 5 is 50, then 6 must be 40. 50 plus 40 is 90. Then we can conclude that angle 4 and angle 6 are, in fact, congruent. That's all these statements are saying. So in this case, let's say this is 30 degrees, and angle 2 is 150 degrees. Well, that adds up to 180. And then they said that angle 2 and angle 3 are supplementary. So that would be forcing angle 3 to be 30 degrees because 150 plus 30 is 180. And then therefore, we can conclude that angle 1 and angle 3 are the same measure or congruent. So we're going to do those proofs next. Okay, so here is example 2, proving the case of congruent supplementary theorem. So it says, use the given two-column proof to write a flowchart proof that proves that two angles supplementary to the same angles are congruent. Okay, so we're going to be given a two-column proof, and we have to do the flowchart proof. I'm not going to spend a lot of time on this, but let me get that in here. Okay, so here we go. There is the two-column proof. So let's just take a look at this first. It says statement, angle 1 and angle 2 are supplementary. So these two angles right here, let me label them. They add up to 180 degrees. So angle 1 and angle 2 are supplementary. Given the measure of angle 1 plus the measure of angle 2 equals 180 degrees, follows from that angle 1 and angle 2 are supplementary. And that's the definition of supplementary angles. So again, we can say that other given angle 3 and angle 2 are supplementary. And therefore angle 3 plus angle 2 equals 180 degrees, and the same reason. So they're just pairing them together so they don't have to write as much. So now we know angle 1 and angle 2 equals 180. Now we can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Well, how can we say that? Well, if angle 1 plus angle 2 equals 180, and angle 3 plus angle 2 also equals 180, if two things are equal to the same thing, they're equal to each other. That is the transitive property of equality. And now if we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2, and I subtract the measure of angle 2 from both sides, okay, measure of angle 2 minus the measure of angle 2 goes away, and we're left with the measure of angle 1. The measure of angle 2 minus the measure of angle 3 or 2 goes away, and we're left with the measure of angle 3, and that's where this comes from. That is the subtraction property of equality. So I just wanted to point that out. Okay, and then once we have two angles that have equal measures, then we can say that they are congruent, and that is the definition of congruent angles. Okay, so now that we've done the statement, reason, two-column proof, now we're going to write it as a flowchart proof. So I bring this down to right here, and the flowchart proof is going to look like this. So we're going to start with angle 1 and angle 2 are supplementary, and that's a given. Angle 3 and angle 2 are supplementary. That is also given. So all I'm doing is writing the statement in the box, and underneath this box, the reason. Pretty simple. Statement, reason, box, underneath is the reason. What does that lead to? Well, that leads to the next line. The measure of angle 1 plus the measure of angle 2 equals 180. And this one leads to the measure of angle 3 plus the measure of angle 2 equals 180. And those are both definition of supplementary angles. So that was just these two with the same reason. So obviously that we're then going to take this and say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. And the reason underneath it, transitive property of equality. And notice the arrows are just pointing to the next step. And after we said that, we can get rid of those angle 2's by subtracting. And we end up with a flow chart that says the measure of angle 1 equals the measure of angle 3 and the reason underneath, subtraction property of equality. And finally, we lead to what we're trying to prove, which is angle 1 is congruent to angle 3. And that is the definition of congruent angles. So flow charts are almost identical to two-column proofs. It's just the layout is different. Okay, now we have postulate and theorem. Postulate 2.8, linear pair postulate. If two angles form a linear pair, then they are supplementary because a line has 180 degrees. So two angles that form a line have to add up to 180 degrees. So angle 1 and angle 2 form a linear pair. So angle 1 and angle 2 are supplementary, and the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Pretty simple. Theorem 2.6 is the vertical angles congruence theorem. And this simply states that vertical angles are congruent. So this is a diagram that is very common. And what they're saying is, if you have two lines that intersect, these two angles are congruent. And these two angles are congruent. The reason is from linear pairs theorem right above. So 2 and 3 form this straight line right here. And straight lines have a measure of 180 degrees. So if angle 2 plus angle 3 is 180, and then I draw another line this way, and angle 3 plus angle 4 equals 180, well, that goes back to the last theorem, where if you have two things that are supplementary, angle 2 and angle 3 supplementary, and angle 3 and angle 4 are supplementary, then angle 2 has to be congruent to angle 4 or equal to angle 4. And all these things just tie together and then start to make other things true. Okay, so we'll take a look at those proofs on the next slide. Okay, example 3, proving the vertical angles congruence theorem. Use the given paragraph proof to write a two-column proof of the vertical angles congruence theorem. Given angle 5 and angle 7 are vertical angles. So the first thing you always should do is label your diagram. Angle 5 and angle 7 are vertical angles. That's given. Okay, they're across from each other. In other words, two lines intersect and they're opposite. That's the given. So in the paragraph proof, it says angle 5 and angle 7 are vertical angles formed by intersecting lines. As shown in the diagram, angle 5 and angle 6 are linear pair. Okay, so what does that mean? Well, let me switch to purple here. Angle 5 and angle 6 are linear pair. So that means 5 plus 6 equals 180. So I'm going to just do that over here. They add up to 180 degrees. And angle 6 and angle 7 are linear pair. Well, here's angle 6 and here's angle 7. So in other words, they're just saying these are straight lines. And when you have two angles that are linear pairs, they add up to 180 degrees. So we want to convert this from a paragraph proof to a two-part proof. And so angle 5 and angle 7 are vertical angles. So over here, you state that angle 5 and angle 7 are vertical angles. And the reason for step number 1 is always given. The next thing that they stated was angle 5 and angle 6 are linear pair. Angle 6 and angle 7 are linear pair. And the reason is definition of linear pair as shown in the diagram. So once you define something like in a previous proof, you do not need to go through that proof again. Once it's done, once you have proven something. So what did we prove back here? Okay, we have a linear pair postulate, we have a vertical angle congruence theorem. And before that, we had congruent supplements theorem, and congruent complements theorem. So once you have all these theorems and you prove them, you can just use the definition of that theorem in your new proofs, and it really cuts down all the work. And the more you do, the less you have to do, and if that makes sense. So then by the linear pair postulate, angle 5 and angle 6 are supplementary. So in my two-part proof, I'd say angle 5 and angle 6 are supplementary, and angle 6 and angle 7 are supplementary by the linear pair postulate, which says that if two angles form a straight line, they're linear pairs, they add up to 180 degrees. And so therefore, then you would put linear pair postulate. Okay, and then finally, oops, what did I hit? Hit something. Angle 5 and angle 6 are congruent. So it says, so by the angle congruent supplements theorem, angle 5 is congruent to angle 7. So in a statement, you would say this, and the reason is congruent supplement theorem. And that is converting a paragraph proof into a two-column proof. Okay, so a lot of students, when we start doing logic and proofs, they're like, why are we doing this? Well, theorems are created. You have to prove things in order to state that that is the case for all cases. And if you don't do that, then we can't do these problems that are in geometry or algebra. So for example, 4, it says using angle relationships, find the value of x. So right here we have two lines that intersect. And whenever you have two lines that intersect, opposite angles, vertical angles, are congruent. So the first thing I would say is the measure of angle QPR equals the measure of angle. So I went QPR is congruent to angle SPT. Okay, the reason for that is vertical angles are congruent. So once we know that vertical angles are congruent because we proved it, now we can just use it to solve equations. So how do I do this? Well, if these two are congruent, they're equal. They're equal to each other. Well, if they're equal to each other, then, well, what is QPR? Measure of angle QPR is 3x plus 1. And what is the measure of angle TPS or SPT? 148 degrees. So once you do that, you have a simple algebraic equation. So geometry is just simply using postulates and theorems to set up algebraic equations to solve for unknowns. And so once you use the geometric postulate or theorem, then boom, we derive an equation from that is solved algebraically. So then all we do is our order of operations for solving for an equation, and that's doing inverse operations to cross an equal sign. So I'm going to subtract 1 from each side, and I'm going to get 3x equals 147. Okay, so that's the subtraction property of equality. I'm not going to write the names of this stuff down, but that's what it is. So what did I do? I said the two angles were congruent because of the vertical angle postulate, and then I substituted in to my equation, that's substitution, and now I'm doing subtraction property of equality. And now if I have multiplication, the inverse of multiplication is division, and that's the division property of equality, and I get x equals, and 3 goes into 14 4 times with a remainder of 2, and 3 goes into 27 9 times. So x equals 49. I'm not done yet. I should always check. So then if I take the measure of angle PQR, 3x plus 1 should equal 148 degrees, and I substitute in my x that I solved, I check it. And 9 times 3 is 27, carry the 2, 4 times 3 is 12, plus 2 is 14. 147 plus 1 does in fact equal 148. So I also should check. So what did I do? I wrote a formula. I substituted the givens. I simplified. I solved. And I checked to see if my answer made sense. Okay, very simple. Same 4 steps every single time. Okay, example 5 says using vertical angles congruence theorem, write a paragraph proof. So the given is angle 1 is congruent to angle 4. That was our given. So in our paragraph proof, we would say angle 1 and angle 4 are congruent by the vertical angles congruence theorem. Actually, I'd stop right there because that was given. And you don't say given. You just say angle 1 and angle 2 are congruent. Stop. Well, after we do that, we're trying to prove that angle 2 is congruent to angle 3. So the next thing we do is say, by the vertical angles congruence theorem, angle 1 is congruent to angle 2. So now I could say angle 1 is congruent to angle 2. And there's another congruent vertical angle, 3 and 4. So angle 3 is congruent to angle 4. So now I know angle 1 is congruent to 4. That was given. Angle 1 is congruent to 2. And angle 3 is congruent to angle 4. So this is leading up to something that's should be pretty obvious. By the transitive property of angle congruence theorem, remember the transitive property, if A equals B and B equals C, then A equals C. So if 1 is congruent to 4 and 3 is congruent to 4, then 1 is congruent to 3 and 2 is congruent to 4. Using the transitive property of angles congruence theorem 2.2, once more, then we can say angle 2 is congruent to angle 3. And that's what we're trying to prove. So let's recap that. So what we're saying is angle 1 and angle 4 are congruent. Angle 1, this one, and angle 2 are congruent. And angle 3 is congruent to angle 4. Those are all by the transitive property. So therefore, angle 2 is congruent to angle 4. And using the transitive property, we can then say angle 2 is equal to 3. So 1 was congruent to 4. 1 was congruent to 2. So that makes 4 congruent to 2. And 3 is congruent to 2. Because 3 was congruent to 4 as well. Because 4 is congruent to 2. So it's kind of like transitive property twice, all wrapped up and proving that all 4 angles are congruent. Okay, concept summary now. Let's finish this up. Types of proofs, geometric or symmetric property of angle congruence theorem 2.2. If you're given angle 1 is congruent to angle 2, we need to prove that angle 2 is congruent to angle 1. So the 2-column proof would be angle 1 is congruent to angle 2. That was given. The measure of angle 1 equals the measure of angle 2, definition of congruent. The measure of angle 2 equals the measure of angle 1. You can switch it around. That's a symmetric property of equality. And then finally, since the 2 measures are equal, then they're congruent. So the angle 2 is congruent to angle 1, and that's the definition of congruent angles. The flowchart proof is just simply taking the statement, reason, statement, reason, statement, reason, statement, reason. And the paragraph proof would look like angle 1 is congruent to angle 2. By the definition of congruent angles, the measure of angle 1 is equal to the measure of angle 2. The measure of angle 2 is equal to the measure of angle 1 by the symmetric property of equality. Then by definition of congruent angles, angle 2 is congruent to angle 1. So there are 3 ways to show that if 2 angles are congruent, angle 1 is congruent to 2, then angle 2 is congruent to 1. Okay, so that's basically proving symmetry. Okay, that brings us to the end of chapter 2.6 exercises. Please do problems 3 through 13 odd, 18, 20, and 31 through 36. Okay, have a great day.